In this video, I'll show you how to solve the ALEKS problem called solving for a reactant using a chemical equation. This problem is going to start off with a little story or scenario. The very first thing we need to do is take the information from this little scenario and use it to write a balanced chemical equation. So this problem is telling us, in this scenario, it's telling us that ethanol, which is CH3CH2OH, ethanol reacts with oxygen gas. So that means ethanol plus oxygen gas, O2, and it forms, forms water. So that means water, H2O, is one of the products. And it also forms acetic acid, CH3COOH, that's our other product. So we're going to start by taking that little scenario and just writing it as a chemical equation. The next thing we need to do is balance this chemical equation, or just make sure that it's balanced. A lot of the equations that you'll write for these problems are just going to be balanced as you write them. So we're just going to count carbons. We have 2 on the left, 2 on the right. Hydrogen, we have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. And oxygen, we have 1, 2, 3. 1, 2, 3. So the equation is balanced the way that it's written. Now we're ready to actually see what this problem is asking us to do. The problem wants us to determine or calculate the mass of ethanol that is associated with 4.96 grams of oxygen gas. So I want you to think about this like a unit conversion problem. I want you to treat it the way you would treat any unit conversion problem. Imagine that you have 4.62 grams of oxygen gas, and your goal here is to convert that into grams of CH3COOH. We just need to find an appropriate conversion factor that will let us do this. All it is a unit conversion. Now, unfortunately, there is no such thing as a conversion factor that lets us go from grams of one molecule into grams of another. The only way that we can do a conversion from one molecule to another is using the moles. So we can convert from moles of oxygen into moles of the acetic acid, CH3COOH. That's a valid conversion. And we also know that using the molecular weight, we can convert from grams of oxygen into moles, and we can convert from moles of, well, anything into grams. So the process that we need to take in order to do this conversion is to go from grams of O2 into moles of O2, and then into moles of acetic acid, and then into grams of acetic acid. We're going to set this up the same way we would set up any unit conversion. That means we want to start by writing the number and the unit that has been provided to us in the problem, the stuff that we're trying to convert out of. We want to multiply by a conversion factor, and this conversion factor, we want to put our unwanted unit down on the bottom of the conversion factor so that it will cancel out. And on the top of the conversion factor, we want to put our desired unit. Now, of course, our desired unit is grams of acetic acid, but we're not allowed to do that in just one step. As we talked about, we have to go from grams to moles. So our desired unit is moles of O2. The relationship between grams and moles of any type of substance is the molecular weight or the molar mass of that substance. So we would get this by looking at a periodic table and adding up the mass of 2 oxygen atoms. 16 plus 16 is 32. I do round molecular weights just to kind of keep things a little bit simpler. I don't recommend that you do that for ALEKS. ALEKS doesn't like that. Use exact molecular weights instead of rounded ones. So that is our first step. And the next step of our conversion factor, because moles of O2 are not the desired units, the desired units are grams of CH3COOH. So we need another conversion factor. We need to put our unwanted unit down on the bottom. The unwanted unit is moles of O2, and our desired unit up on top. Our desired unit this time, so now we're working on this step of the conversion. Our desired unit is moles of CH3COOH. And in terms of the relationship or the numbers that we'll use in this conversion factor, this conversion factor comes from the stoichiometric coefficients in the balanced chemical equation. So for the moles of O2, the number that we would put right here is the number, the stoichiometric coefficient in the balanced equation, which is just 1. And for the CH3COOH, the number that we would use for that is its stoichiometric coefficient, which is also just a 1. So mathematically, nothing is actually happening in this step, but that's not always going to be the case. Most of the time, it's not going to be a 1-to-1 ratio in this step. Now we need one more conversion factor, again, because the moles of acetic acid are not what we want. We are trying to calculate grams of acetic acid. I'm going to give myself more room here. And again, the relationship between moles of anything and grams of anything is the molecular weight or the molar mass of that particular substance. So we are going to access a periodic table and we're going to add up the masses of all of the atoms in this molecule. Carbon is 12, hydrogen each are 1. Carbon again is another 12, 2 oxygens, and 1 more hydrogen. This adds up to, like, I feel like I need to use my calculator for this. 12 plus 3 plus 12 plus 16 plus 16 plus another 1 is 54. Nope, I hit 60. 60 grams per mole. Those mole units cancel out. And again, I do round my molecular weights because I'm lazy, but I do not encourage you to do that. You need to pull out a periodic table and get the exact atomic masses for all of these so that you get a more accurate molar mass. So your molar mass is not going to be 60. It's going to be 60 with a little bit more detail out here. You're going to have some decimal points out here. ALEKS does not like it when you round molecular weight, so don't do that. So we're just going to do the math on this. 4.96 divided by 32 times 60. The answer wants this to 3 significant figures. My calculator gives me 9.3 grams. And if I was going to put this into 3 sig figs, I would use 9.30 grams. But again, you're not going to get 9.3 if you do this because you are going to use exact molar masses, not rounded molar masses. So your number is going to be in the ballpark of 9.3, but it will have more accuracy to it.